Tonight we are going to look up at the sky and we are going to wonder. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. The sky above your roof, above this house, above this hemisphere, is the thinnest of skins. It wraps the whole planet in a soft blue layer, no thicker than the white of an apple. And yet, for as long as people have written things down, that thin blue skin has been letting things fall. Not just rain, not just snow, other things, quiet, strange things. Picture the Earth from a great height, a slow turning ball of ocean and cloud. The cloud layer is delicate, almost lacy, drifting in long curls across the blue. From this far away, the air seems empty. It is not. The air is a vast, slow river. It carries dust from the Sahara across the Atlantic. It lifts pollen from forests in spring. It holds whole storms in its currents. And inside those storms, tiny things ride on rising winds. Sometimes those things come back down. The records go back a very long way. Ancient scribes in Rome wrote of stones that fell from a clear sky. Old chronicles from China described rains the color of blood. Medieval villagers spoke of fish flopping in puddles where no river ran. Farmers in the American South have told stories of frogs landing on barn roofs. Sailors have written of small jellyfish dropping onto wet decks. Travelers in the high deserts have watched red dust settle on white tents and stain them the color of rust. None of this is folklore alone. Some of these events were studied by careful people. Some left samples in jars. Some were reported in newspapers the very next morning, with names and dates and quiet, puzzled witnesses. And yet, even now, the full explanation has slipped through our fingers. We have ideas. We have good ideas. We do not have one tidy answer. That is the open question we will sit with tonight. Why does the sky every so often, in quiet corners of the world, let unexpected things fall? Not as a single mystery, but as a long, soft chain of small mysteries woven across centuries and continents. There are theories, of course. One of the gentlest is the waterspout idea. A waterspout is a slim funnel of spinning air that touches down on a lake or a shallow bay. It can lift water, and with the water, small living things. Then it travels inland, weakens, and lets its cargo drop somewhere far from where it began. This idea works well for fish. It works less well for stones, for jelly, for colored powders. Another idea is the long reach of the wind itself. Storms can carry dust thousands of miles. A red haze rising from the Sahara can drift across an ocean and tint the rain in Europe. Pollen, ash, and tiny spores ride these high currents like passengers on a slow train. When the moisture finally falls, the passengers fall with it. And then there are the events that do not quite fit either picture. Glowing falls, soft jellies in the morning grass, coins or bits of metal, reported in old papers with careful, sober language. For these, no single theory feels complete. Some researchers wonder if several mechanisms overlap. Others suspect that some accounts are mistaken, or that the strange object was already on the ground and only seemed to fall. The honest answer is that we do not always know. What is certain is the sky itself. The sky is not the empty space we sometimes imagine. It is a living layer, full of motion, full of tiny travelers we cannot see. Pollen drifts at the height of small birds. Spores of fungi float in the cold upper air. Whole ecosystems of microbes have been found riding the winds far above the clouds. The atmosphere is a slow ocean, and like any ocean, it sometimes lets its contents wash up on shore. So tonight, as you settle in, Let your mind rest on this gentle thought. You are lying under that thin blue skin. Above you, the air is moving in slow rivers. Somewhere, far away, something small may be lifted by a quiet column of rising warmth. Somewhere else, perhaps tomorrow, perhaps 100 years from now, that small thing will fall again, and someone will look up, puzzled and curious, and add their account to the long, soft record of strange things that have come down from the sky. We will spend the next hours wandering through that record together, slowly, without hurry, with wonder. Long before there were weather reports, long before there were even printed books, people kept records of stones that fell from the sky. These records appear in clay tablets, in scrolls, in temple inscriptions, and in the careful handwriting of monks who copied old texts by candlelight. The stones were not common, but they were not rare enough to be ignored. Across thousands of years, in lands that never traded notes with each other, the same strange story keeps appearing. Something hard and heavy came down out of the open air. The simplest of these falling stones are what we now call meteorites. A meteorite is a piece of rock or metal that travels through the upper air and lands on the ground. Most are small. A typical meteorite that reaches the surface is about the size of a pebble or a fist. Some are no bigger than a grain of sand. A few, very rarely, are as large as a car or a small house. The ones that grow famous in old records are usually the size of a melon or a loaf of bread, big enough to be noticed, but small enough to be carried home and kept. These stones are old. Most meteorites that land on Earth are around 4.5 billion years old, which is older than the planet's oldest mountains, older than its oceans, older than life itself. They are leftover material from the early days of the solar system, drifting quietly until Earth's gravity pulls them in. When you hold a meteorite in your hand, you are holding something that was already ancient when the first single cell appeared in the sea. That fact alone is enough to make a person sit very still for a moment. The composition of these stones falls into a few simple groups. Some are made mostly of rock, much like the stones you might find in a garden, though their inner structure looks different under a microscope. Some are made mostly of metal, a heavy mix of iron and nickel that feels strangely dense in the palm. A small number are a blend of the two, with bright metal flecks shining out of dark stone. The metal ones are what ancient peoples sometimes shaped into knives and ornaments, long before they knew how to mine iron from the ground. The oldest written account of a falling stone that we can still read comes from ancient Egypt and from the lands of the Hittites more than 3,000 years ago. Hittite texts speak of black iron that came from the sky and was treated as a gift. The Egyptians made beads from sky iron, threading them onto necklaces meant for kings. A small dagger found in the tomb of one young pharaoh was later tested by modern scientists. The blade turned out to be made of meteorite metal, hammered cold and polished until it shone. Whoever made it knew the stone had come from above. The Greeks and Romans wrote about these falls as well. A stone said to have landed near the town of Ecopotami in the year 467, before the Common Era was described as roughly wagon-sized and brown in color. The historian Pliny mentioned it centuries later. Whether it was really that large, or whether the size grew in the retelling, is one of those small uncertainties that float through the old records. We have the words. We do not have the stone. In China, careful court astronomers kept lists of these events for nearly 2,000 years. They noted the date, the place, the sound, and sometimes the color of the falling object. In Japan, a stone that fell in the year 861 is still kept in a shrine, wrapped in cloth, treated with quiet respect. In the deserts of Arabia, dark stones from the sky were set into the walls of holy places long before anyone tried to explain where they came from. For most of human history, scholars were not sure what to make of these accounts. Some believed the stones truly came from above. Others insisted that stones could not fall from the sky because there was nothing up there for them to fall from. It was not until the late 1700s that careful study began to confirm what village witnesses had been saying all along. Rocks really do arrive from the air, and the sky really does, on rare occasions, drop a piece of itself onto the ground. This is the steady, well-documented part of our mystery. The harder part begins when the things falling are not stones at all, but living creatures, colored water, soft jellies, and stranger matter still. Those are the falls we will sit with next. Of all the strange things people have reported falling from the sky, fish may be the oldest and most stubborn pattern. The reports stretch back across centuries and continents, written down by farmers and priests, by sailors and shopkeepers, by people who had no reason to invent such a thing. They describe small silver bodies scattered across rooftops. They describe minnows wriggling in puddles where no stream runs nearby. They describe quiet villages that woke one morning to find their gardens dotted with fish. The earliest written accounts come from the ancient world. A Roman writer named Athenaeus, working in the 3rd century, mentioned a town where it was said to have rained fish for 3 days. Whether the story was already old by then, no one can say. What we do know is that similar reports appear again and again in later centuries, in places far apart, told by people who had never read each other's writings. A village in India, a field in Wales, a street in Singapore, a meadow in Honduras, where a yearly event known locally as the Lluvia de Peces, or rain of fish, has drawn quiet attention for generations. The Honduran case is one of the strangest. Each year, during a certain stretch of the wet season, villages near the town of Yoro report finding small silver fish scattered across the ground after heavy storms. The fish are alive, or have been alive moments before. They are usually freshwater fish, often of a single species. The nearest large body of water lies miles away. Researchers have visited, theories have been offered. The full picture remains uncertain. How could such a thing begin in the first place? To understand the origin of these reports, it helps to imagine the conditions that might lift a fish from water and carry it through the air. One leading idea points to waterspouts, tall spinning columns of wind that form over warm seas and lakes, drawing water and small living things upward into their course. A strong waterspout can pull spray hundreds of feet into the sky. In theory, light creatures swept into the column could be carried along with the moisture, lifted into a passing storm cloud, and then released later when the storm moves over land. That is the most common explanation, yet it leaves much unanswered. Waterspouts are usually visible. Witnesses to a fish fall rarely report seeing one nearby. The fish that fall are often a single species, of a single size, as if sorted by some unseen hand. A whirlwind tearing across a pond should pick up plants, mud, frogs, snails, and water all at once. The neat, selective nature of many falls does not match the messy reality of a spinning column of wind. A second idea suggests strong updrafts within thunderstorms themselves. These rising columns of warm air can lift hail to great heights, holding stones aloft until they grow heavy enough to fall. Could the same updrafts, passing over shallow water, lift living creatures along with the spray? Possibly. But here too the evidence is thin. No one has yet observed the moment of lifting, in a way that resolves the question. A third possibility, quieter and less dramatic, is that birds sometimes drop their catch. Flocks of pelicans, herons, or gulls flying over land have been known to release fish when startled or when their loads grow too heavy. This could explain small, scattered events. It does not easily explain the larger ones, where hundreds of fish fall over a wide area in a short span of time. So the origin story of the falling fish mystery is really the origin story of an unsolved puzzle. The reports are too old, too widespread, and too consistent to dismiss. The mechanisms we know about each explain part of the pattern. None of them explain all of it. The atmosphere, it seems, is capable of moving more than just water and dust. Living things can ride within it, lifted in ways we have not fully traced, set down in places that have no obvious link to where they began. There is something deeply old feeling about a shower of fish. It belongs to the same family of events that ancient people once read as signs from the heavens. They saw the silver bodies on the wet earth and felt that the sky had spoken. Today we look for spinning winds and high clouds and updrafts and birds. We sketch out diagrams and gather samples when we can, and still the question hovers above us, unfinished, waiting for the next fall to be witnessed and described by someone standing quietly in a garden, in a field, on a street, looking up at a sky that has once again let something soft and strange come down. Of all the strange falls recorded across the centuries, the falling of frogs may be the oldest and the most often repeated. Roman writers spoke of it. Medieval chroniclers wrote it down. In calm, matter-of-fact prose, village priests in France, farmers in England, travelers in Greece, all left behind quiet accounts of small frogs landing in the grass after a sudden storm. The frogs were usually alive. They hopped away into the wet fields as if nothing unusual had happened at all. To wonder about how this could be, it helps to think about what a frog is actually made of. A small frog is mostly water. Its soft body holds the same salts and sugars and proteins that float in any pond. Its bones carry calcium, the same calcium that built the white cliffs of Dover from the shells of tiny sea creatures over many millions of years. Its blood carries iron, the same iron that gives rust its color and gives the Earth's deep core its slow, heavy pull. Every atom inside that small green body was once part of something else. The iron was forged inside an ancient star that lived and died long before our planet existed. The water in its cells may have arrived on icy comets during Earth's young, hot childhood. So when a frog falls from the sky, in a strange way, it is matter returning to the air it once passed through. Water lifted from the pond becomes cloud. Cloud cools into rain. Rain falls back into the pond where the frog was born. The frog drinks that rain. The frog itself becomes, for a moment, a small package of pond water with legs. And then, on certain rare days, the pond water with legs is carried up into the cloud as well. The leading theory for how this happens involves waterspouts. A waterspout is a spinning column of wind that touches down on a lake or a sea. It is a tornado made of moist air. It pulls upward with great force. Anything light enough. Leaves, fish, small frogs, even sand and weed can be lifted into the storm above. The storm carries this strange cargo across the sky. When the updraft finally weakens, the cargo falls. This idea explains many cases. It does not explain all of them. In some old reports, the frogs fell from skies that held no nearby storm. In others, only frogs fell. No leaves, no pondweed, no fish, no mud. A waterspout should lift whatever floats on the water surface, not sought by species. Some researchers wonder if there is a second mechanism at work. Perhaps something about how dense, similarly shaped objects sort themselves inside a turning column of air. Others suspect that in many cases, the frogs were not falling from the sky at all. Heavy rain can flush young frogs out of nearby grass and ditches all at once, making the ground seem suddenly alive. The truth, for any single event, is often hard to pin down years later. The building blocks of a frog fall, then, are not only the frog, they are the warm sun pulling water upward from a shallow lake. They are the cold, high air that makes that water gather into cloud. They are the wind shear that begins the spin. They are the calcium in bone, the carbon in skin, the salt that the frog's body brought up from its home water. And they are the witnesses below, standing in muddy boots, looking up at a sky that has just done something quietly impossible. There is something soft and humbling in this picture. The atmosphere is not empty. It is a thin, restless ocean of gas, full of dust and pollen, and tiny seeds and floating spores, and bacteria carried on the wind. Scientists who study this hidden layer call it the aerobiome, the living film of small things drifting through the air. A frog inside a thundercloud is just a larger member of that drifting crowd, a heavier passenger on a route that pollen has traveled for a very long time. The mystery is not that the air can carry things. The mystery is in the details. How high did the frogs go? How long did they spend up there? Why some species and not others? Why the falls cluster in certain regions and certain seasons? We have pieces of the answer. We do not have the whole shape of it tonight. As the wind moves quietly over fields somewhere in the world, it is enough to picture a small green body made of pond and starlight, riding the warm breath of a summer storm. Of all the strange things the sky has been said to drop, perhaps none has unsettled the human mind quite as gently and quite as deeply as rain that arrives in the wrong color. Most rain falls clear, or grey, or silvered by the light of a late afternoon. But every so often, across many centuries and many countries, people have stood beneath a sky that opened and let down something tinted, red, yellow, black, a soft, milky white. The drops landed on rooftops and on the backs of grazing animals, on washing left out to dry, on the pale stones of village squares, and the people who saw them did not always know what to think. To wonder why this happens, we have to think about the quiet forces that shape the sky itself. The atmosphere is not empty. It is a thin shell of moving air, wrapped around the planet, churned by heat from the sun and pulled downward by gravity. Warm air rises, cool air sinks, winds curl in long invisible rivers above our heads. And inside those rivers, tiny things ride along, lifted by the simplest force of all, an upward push of warm rising air. That upward push can carry surprising weight, a grain of desert sand, a spore from a forest floor, a drop of seawater flung from the crest of a wave. Once, a particle is light enough, the wind treats it almost like a feather. It can travel for days, it can cross oceans, it can rise high enough to meet the cold layers where water gathers into clouds. And there, if conditions are right, it can become the small invisible seed around which a raindrop forms. This is one of the gentle theories behind colored rain. The droplets are not colored on their own. They are colored by what they wrap themselves around. Saharan dust, lifted by hot winds off the African deserts, has tinted rain a soft orange across southern Europe many times over the years. The particles are heavy with iron, and iron, when it meets water and air, takes on the rusted color of old earth. Scientists have measured these dust clouds, traveling thousands of miles, sometimes reaching as far as the Caribbean. But dust is not the only candidate. In the summer of 2001, in the southern Indian state of Kerala, rain fell that was deeply, startlingly red. It stained clothing. It puzzled farmers. When researchers studied the droplets under microscopes, they found tiny round particles, each about the size of a red blood cell, colored a rich reddish-brown. One team argued the particles were ordinary spores from a local algae lifted into the clouds. Another group of scientists wondered if the spores behaved in ways that did not quite match anything known. The debate has continued, quietly, for more than 2 decades. The simplest explanation, wind-blown algae, fits most of the evidence, yet some details have never fully settled, and the case remains an open one in the corners of atmospheric science. Ancient Rome recorded rain the color of blood. Medieval chroniclers wrote of yellow showers that left fine powder on church steps. In the 1800s, French villages spoke of red rain that vanished into the soil and left nothing behind to study. Without modern instruments, those witnesses could only describe what they saw and guess at what it meant. Many treated it as an omen. We now suspect that most of those old accounts were dust from distant deserts, lifted by storms no one in the village had seen, then folded into the clouds above. Still, the forces that make this possible are remarkable when you sit with them. Heat from the sun lifts a particle off a far desert. Wind carries it across the sea. Pressure drops as the air rises. Water condenses around it. Gravity, patient as ever, eventually pulls the droplet back down. And the particle that began its journey on a dune in North Africa ends it on a roof tile in a quiet European town, tinting the rainwater a color no one expects. What makes the question genuinely unresolved is not whether dust and spores can travel. They can. Whether every colored rain throughout history fits neatly inside that explanation, or whether some of them are caused by something we have not yet identified. The trouble is that rain ends quickly. By the time anyone thinks to collect a sample, the puddles have dried and the wind has moved on. Whole events vanish before they can be studied. We are left with the testimony of those who stood beneath the strange sky, and with the slow, drifting forces of the atmosphere itself, still carrying things across the world tonight, unseen. Let us pause for a moment and think about ice. Not the soft, friendly ice in a glass of water, not the slow ice of a frozen pond. The ice that sometimes falls from the sky, in chunks and slabs, in lumps and stones, in shapes that seem far too large for any cloud to hold. To understand the mystery of strange falls, we must sit with the simple weight of what has been recorded. Real ice, real impacts, real holes in the ground. Imagine a hailstone the size of a pea. It weighs almost nothing. Now picture one the size of a marble, then a grape, then a golf ball. The largest hailstone ever measured in the United States fell in the year 2010 in a small South Dakota town. It was the size of a soccer ball, about 8 inches across, nearly 2 pounds in weight. To hold it in your hand would be like holding a heavy melon, cold and rough and almost too big to grip. That kind of stone, falling from the heart of a thunderstorm, can reach the ground at over 100 miles per hour. Think of a stone falling faster than a highway car. Now multiply that by hundreds, thousands, sometimes millions of stones in a single storm. The roar of a great hailstorm is a sound that listeners often describe as 100 drums beating at once on a tin roof. This kind of hail, while large, still has a clear explanation. Strong updrafts inside a tall storm cloud lift droplets high into the freezing air. The droplets ice over, fall, get lifted again, gather another layer, and grow like onions, ring by ring, until the cloud can no longer hold them. Slice one open, and you can see those layers, like the growth rings of a small frozen tree. The mystery begins when the sky above is calm, blue, empty, and yet ice falls anyway. These events have a name. Some researchers call them megakryometeors. The word is long, but the meaning is simple. Mega for large, cryo for cold, meteor for a thing that falls, large cold things that fall. They are blocks of ice, sometimes weighing a few pounds, sometimes weighing more than 100 pounds. Some have been the size of a microwave oven. A few have been the size of a small refrigerator. They strike roofs, fields, parked cars, with the sound of a heavy gong. The mystery is this: where do they come from when there is no storm overhead? One theory points upward, to the high plains that cross our sky. Ice can build on the outside of aircraft. Sometimes it breaks loose, sometimes it falls. Many recorded icefalls do match flight paths. And chemists who study the chunks have found traces of jet fuel or treated water inside the layers. Case closed, some would say, but not every case fits. Spanish researchers studying a wave of ice falls in the year 2000 noted that several large blocks fell far from any flight route. Some fell in places where the air above had been calm for hours. The chunks weighed up to 80 pounds. They left small craters in the ground. Some were studied in laboratories and showed layers, just like hailstones, only larger by orders of magnitude, as if the sky had grown them quietly, somewhere we cannot see. So a second theory was born. Perhaps the upper atmosphere, far above the clouds we know, sometimes forms ice in ways we do not yet fully understand. Perhaps unusual cold pockets at high altitudes can grow a stone in slow stages until it tumbles down through clear air. The idea is still debated. The evidence is thin. The sky is, for now, keeping its answer. To feel the scale of all this, picture standing in a quiet garden on a warm afternoon. The grass is soft. The light is gentle. A single sound interrupts the calm, a deep thud in the soil 10 feet away. You walk over and find a block of ice the size of a loaf of bread, half buried, slowly melting. The sky above is blue from edge to edge. No clouds, no plains, just ice where ice should not be. Records of such moments stretch back many decades. A chunk in Germany, the size of an elephant, was said to fall in the 1800s, though that story may have grown in the telling. Smaller, well-documented falls have been collected in Spain, in Australia, in the United States, in Brazil. They are rare, they are real, and the people who study them still gather in small groups, comparing notes, holding cold samples in gloved hands, and wondering, quietly, what mechanism the sky has used this time. The question stays open, drifting above us like the ice itself. Picture a quiet meadow at dawn, the kind that lies just beyond a sleeping village. The grass is bent under a heavy dew. The light is soft and grey, and the air still holds the cool memory of night rain. As you walk through this field, you notice something strange in the grass at your feet. Small, pale, glistening blobs of jelly are scattered across the ground. They are not quite clear, not quite white. They look a little like raw egg white, a little like soft glass, a little like nothing you have ever seen before. These pale clumps have a name, people. In old country traditions called them star jelly, or star slime, or sometimes star rot. They are soft to the touch, slightly cool, and they wobble when you nudge them with a stick. Each blob is perhaps the size of a coin, sometimes the size of a small plum. They sit on the grass as though they had drifted down very gently in the night, which is, in fact, how people have always described them. They arrive after rain. They arrive after meteor showers. They arrive in fields where no one was watching. If you knelt down to look closely, you would see something even stranger. The jelly is almost translucent. Light passes through it with a faint pearly sheen. Inside, there are no clear shapes, no veins, no fibers, nothing that obviously looks like a living thing. It is just a soft, formless mess. By mid-morning, when the sun climbs over the hedgerow, the blobs begin to shrink. By midday, many of them are gone. They leave only a damp patch on the grass, as if the field itself had reabsorbed them. This is the texture of the mystery. A thing that arrives quietly, refuses to be studied for long, and melts away before science can reach it. Reports of star jelly stretch back at least 700 years. Old English writings from the 14th century mention a strange substance found in fields, called by names that translate roughly to star shot or star slime. Welsh folklore spoke of poudre sere, the rot of the stars. Farmers in Scotland described it. Travelers in France described it. People in the American countryside described it. The descriptions, across centuries and continents, are remarkably similar. A pale, soft, jelly-like material lying on grass or in shallow pools, often after a night of meteors or heavy rain. The natural question is what the jelly actually is. And here, the theories begin to gather, none of them complete. One idea is that star jelly is the swollen remains of frogs or toads. When certain predators eat amphibians, they sometimes leave behind the jelly-like material that surrounds frog eggs, called oviducts. This material can swell to many times its original size when soaked by rain. Scientists have tested some star jelly samples and found exactly this. The DNA inside matched common frogs, so at least some falls of jelly are not falls at all. They are simply the leftover parts of small animals, hidden in the grass, swollen by water, and noticed at dawn. A competing theory points to a kind of freshwater bacterium called nostoc. This organism forms soft, gelatinous colonies that can sit shriveled and almost invisible on soil. When rain falls, they swell into translucent blobs that look exactly like the jellies described in old folklore. Some samples of star jelly, when tested, have indeed turned out to be nostoc, yet there are samples that match neither. There are recorded cases where the jelly was collected quickly, sealed in jars, sent to laboratories, and tested with care. In some of those tests, no DNA was recovered at all. No cells, no organic structure that anyone could identify. The material simply seemed to dissolve into water and disappear. Whether this means the samples were contaminated or degraded or genuinely strange remains an open question. There are also the older accounts that link the jelly directly to falling lights in the sky. Witnesses describe seeing a bright streak overhead, then finding the jelly the next morning in the field below. Modern science doubts this connection. Meteors burn up high in the atmosphere and rarely reach the ground as anything but small stones. Soft jelly seems an unlikely thing to survive that fall. Yet, the folklore is consistent, and the witnesses were not all imagining the same thing by accident. So we are left in this quiet meadow at dawn with a small pale blob in the grass. It may be the remnant of a frog. It may be a swollen bacterial colony. It may be something else entirely. The field does not say. The jelly only sits there, glistening, waiting for the sun to come and erase it. Of all the strange things that fall from the sky, none feel quite so unsettling as birds. Fish can be explained by waterspouts. Frogs can be lifted by storms. But birds already belong to the air. When they drop in sudden numbers, in silence, across a quiet field or a sleeping street, the mystery feels closer to home. The sky is their place, and yet, every so often, the sky lets them go. The records of these events are scattered through old newspapers and modern reports alike. A flock of blackbirds tumbling onto rooftops in a small town. Starlings found in soft heaps along a country road. Doves resting in stillness on garden lawns at first light. In some cases, dozens. In others, hundreds. The bodies appear intact. There is no sign of storm, no sign of struggle, no clear cause that a person standing in the dark can name. For a long time, such falls were read as omens. Villagers spoke of them in hushed voices. Old chronicles describe birds dropping before plagues, before wars, before changes no one understood. The pattern of meaning was woven by people trying to make sense of something that seemed beyond sense. The birds themselves stayed silent on the matter. Modern researchers have offered several careful theories. One idea is that birds in tight flocks can collide with unseen objects in the dark, buildings, power lines, towers, and fall together in a sudden cluster. Migrating species often fly at night, navigating by stars and faint cues in the magnetic field of the Earth. A bright light or a strong gust can pull a whole group off course. If they strike something solid, the impact ripples through the flock in an instant. Another theory involves sudden weather. A cold downdraft inside a thunderstorm can pull warm, lighter air downward at great speed. A flock caught in such a column might be slammed towards the ground before any of them can recover. Hailstones, too, have been blamed in some cases. Small ice pellets striking a flock at high altitude, knocking birds from the sky in a brief, invisible storm. The sky above looks blue minutes later. Only the ground holds the evidence. There are also quieter explanations. Some bird falls have been linked to poisoning, grain treated with chemicals, or toxic algae in a distant pond. Some have been linked to disease, when a flock already weakened by illness happens to come down in one place, and some have been linked to fireworks or loud sounds at night, which can startle roosting birds into panicked flight in the dark, where they have no map and no time to find their way. Yet, not every case fits these theories neatly. Researchers studying one well-known event in the central United States, where thousands of blackbirds came down on a single New Year's Eve, found injuries consistent with mid-air collisions, but could not say with certainty what triggered the flock to take off in such confusion. Several ideas were offered. None could be fully proven. The birds had left no message behind. What makes these events so quietly strange is the silence around them. A waterspout leaves a trail. A storm leaves clouds and wind. But a bird fall often happens without warning. Sometimes under a calm sky, the bodies simply present at sunrise where they had not been the night before. The cause must be guessed at from the scene alone. And the scene is always incomplete. There is something tender, too, in how the world responds. Local officials gather the birds. Scientists send samples to laboratories. Reporters write careful sentences. People in the neighborhood stand at their fences and wonder. The mystery becomes a shared one, briefly, before the news moves on, and the field is quiet again. For the listener, drifting towards sleep, it is worth holding the larger picture in mind. Birds are among the most common animals on Earth. Many billions of them fly each year through skies crowded with weather, light, and obstacles old and new. That sudden mass falls are rare, may be more remarkable than that they happen at all. The sky is busy in ways the eye cannot follow, and still, the deeper question lingers. Why these flocks, on these nights, in these places? Why 1,000 birds in one small town, and none in the next valley over? The patterns refuse to settle. Each event is its own quiet story, and most of those stories end with a question rather than an answer. The birds, who knew the air better than we ever will, took their reasons with them. We are left to look up at the dark and wonder what passed through it, just out of sight, in the hours before dawn. Not every fall from the sky brings creatures or colored dust. Sometimes the rain itself arrives darkened, heavy with soot, falling in slow grey drops that stain whatever they touch. This is black rain, and it has been recorded for as long as people have kept written records. It tends to follow great fires, burning forests, burning cities, burning volcanic slopes. The smoke rises, the moisture gathers around it, and the sky returns the ash to the ground in a strange dark drizzle. The pattern repeats across centuries, which is why this part of the story belongs to the rhythms of the sky. Fires burn, soot rises, clouds form, dark rain falls, then the wind clears, the air sweetens, and the world goes quiet again until the next great burning. It is a slow pulse, hidden inside ordinary weather. Most people never see it, but somewhere on Earth, in some season, the cycle is always turning. The science behind it is fairly well understood, at least in its broad shape. When a fire burns hot enough, it lifts tiny particles of soot and ash high into the atmosphere. These particles act as seeds for water droplets. Vapor gathers around them. The droplets grow heavy, and eventually they fall. The soot rides down with the water, and what arrives on the ground looks like ink mixed with rain. Old buildings turn streaky. Snow becomes grey. Puddles shimmer with a thin, oily film. What remains less settled is why some black rains seem far darker, far stranger than the fires that came before them. Witnesses have described drops that left black smudges on white cloth, even when no nearby fire was known. They have written of rain that smelled faintly of burning, of pine, of something sharp and metallic. Days after the nearest blaze had been put out. One idea is that smoke can travel enormous distances through the upper atmosphere before finally falling as rain. A fire in one country can stain the sky of another. Another idea is that volcanic ash, lifted high during eruptions, can drift for weeks and see dark precipitation far from its source. Both ideas hold real weight. Which one explains any particular event is often impossible to say. History offers many examples to wonder about. After the long fires that swept the American forests in 1780, a darkness fell across New England that people still call the Dark Day. The sky turned the color of old copper. Candles were lit at noon, and in some places, rain came down stained and sooty, leaving black streaks on the laundry hung outdoors. The cause is now thought to be massive wildfires, drifting smoke eastward, mixed with low cloud and fog. But at the time, no one could explain it. People prayed. People watched the sky. The cycle of fire and soot and stained rain played out before they had the words for it. Other accounts come from the slopes of volcanoes. After certain eruptions, villages downwind have reported rain so dark it looked like weak coffee. Roofs turned grey. Streams ran cloudy for days. The ash itself was harmless in small amounts, but it coated everything, and the rain spread it further than the wind alone could carry. There is a quieter mystery folded inside all of this. Black rain is not only a record of one fire, it is in some ways a record of the whole atmosphere. The soot that falls in one valley may have come from a forest hundreds of miles away. The ash that darkens a city may have risen from a volcano on the far side of an ocean. Each black drop is a small message about where the wind has been. Reading those messages is difficult. Scientists can study the chemistry of the soot and sometimes trace it back to its source, but the full path the particles took, how high they rose, which currents they rode, how long they drifted before the rain claimed them, often stays uncertain. The cycle continues today. Wildfire smoke from one continent shows up in the rain of another. Volcanic plumes drift for thousands of miles before settling. The sky breathes in the ash of our burning world and breathes out a dark, quiet rain somewhere else, sometimes weeks later, sometimes farther than anyone would guess. There is something steadying in this. Even as it deepens the mystery, the sky remembers fires. It carries their traces in slow, patient currents. And every so often, when the conditions are right, it returns those traces to the ground in droplets that look like night. We can describe the cycle. We can sketch its outline. But the full path of any single black drop, from flame to falling, remains its own small, unsolved story. There is a quiet kind of falling that does not involve animals or strange jellies. It is the slow drift of dust and pollen and ash from far-off places, carried on high winds and laid down softly on roofs and fields and snowbanks. These are the neighbors of the stranger falls. They are the gentler cousins of the unexplained, and they remind us that the sky is always carrying something, even when it looks empty and blue. In the early spring, in parts of Russia and Siberia, people sometimes wake to find the snow tinted yellow, not a deep yellow, but a soft golden dusting, as if someone had brushed the white drifts with pale paint. The first time you see it, it looks wrong. Snow is supposed to be white, but this yellow snow has a simple visitor inside it. It is pollen, lifted from distant forests, carried up into the cold air, and folded into the falling flakes. When the snow lands, the pollen lands with it, and the whole landscape takes on a faint, warm glow. Other times the snow turns pink or orange, or even a dusty rose. In the high mountains, pink snow sometimes comes from tiny algae that live inside the ice and bloom in the warmer months. But pink snow can also come from above. Saharan dust, lifted by storms in North Africa, can ride the upper winds for thousands of miles. It drifts across the Mediterranean, it crosses Europe, it settles on the Alps, and when it falls with the snow, it leaves behind a layer of warm-colored grit that turns whole mountainsides the color of weak tea. This is the wider family that the stranger falls seem to belong to. The atmosphere is not empty. It is a slow, broad river of small things: pollen, spores, bits of soil, salt from the sea, tiny crystals of clay lifted from cracked riverbeds, even bacteria drifting along at the edge of the clouds. When rain or snow forms, it forms around these little specks. Every drop has a quiet passenger at its heart. Every snowflake begins with a guest. That is one reason colored rain is not always mysterious. Sometimes the color simply comes from the dust the rain was built around. A red rain over southern Europe may carry the iron-rich soil of the Sahara. A yellow rain over a farm field may carry pine pollen from a forest hundreds of miles upwind. The drops fall, the water dries, and a thin colored film is left behind on cars and windows and stones. But this is also where the mystery begins again, because dust and pollen explain many colored rains. They do not explain all of them. Some falls carry colors that do not match any nearby source. Some carry strange textures or odd smells or particles that researchers struggle to identify even with careful study. The Kerala red rain in southern India, which fell across several weeks in 2001, became one of the most studied colored rains in modern history. One leading idea points to spores from a local kind of algae. Another idea, less accepted but still discussed, suggested something more unusual. The debate stretched on for years. Even now, not every researcher agrees on the final answer. So the neighbors of the mystery are themselves a little mysterious. The yellow snow is mostly pollen, and yet sometimes a sample turns up something unexpected. The Saharan dust is mostly fine red clay, and yet sometimes it carries living microbes that survive the long flight. The atmosphere keeps blurring the line between the ordinary and the strange. It carries known things in known ways, and then, every so often, it brings down something that does not quite fit the pattern. There is a soft beauty in this idea. The sky above any quiet village is connected to deserts you have never seen, to forests on the other side of an ocean, to algae blooms in shallow seas, to volcanoes that erupted weeks ago in another hemisphere. The dust on your windowsill may have begun its life as a grain of sand in the Sahara, or as a fleck of soil from the Gobi, or as a puff of pollen from a pine ridge in Canada. The neighbors of the falling things mystery are not really neighbors at all. They are old travelers arriving from very far away. And perhaps the stranger fools. The fish, the frogs, the colored rains that no one can quite explain, sit somewhere along this same long road, carried up by forces we partly understand, set down again by forces we have not yet fully mapped. The sky, it seems, is always delivering small parcels from elsewhere. We only notice when the parcel is unusual enough to make us look up. Of all the strange things that have ever fallen from the sky, the ones with the longest written record are stones. Stones that arrived burning, stones that hissed when they struck cold ground, stones that came down from places no one could quite point to. These are the meteorites, and the lore around them stretches back nearly as far as writing itself. They sit at the far edge of our topic, the most extreme example of the sky giving up something solid. The oldest meteorite known to have been seen falling and then carefully kept by people is sometimes said to be the Nogata stone in Japan. Witnesses watched it arrive in the year 861 on a quiet evening near a small shrine. The stone was placed in a wooden box and tucked away. Over 1,000 years later, scientists were finally allowed to test it. The rock truly was a meteorite, a piece of the early solar system, kept safe in a shrine for more than a millennium, because the people who saw it fall understood, somehow, that it mattered. Older stories exist too, though they are harder to verify. The ancient Greeks wrote of a great stone that fell at Ecopotami around 467 before the Common Era. Some accounts say it was the size of a wagon and burned as it came down. Whether the stone itself still survives is uncertain, but the story was repeated for centuries, copied from one historian to the next. In ancient Rome, a dark stone that fell from the sky was carried in solemn procession and worshipped as sacred. The Kaaba in Mecca contains a black stone whose origin remains debated, though many have wondered for centuries whether it too came from above. What makes meteorite lore so striking is how often the falls were doubted. For most of recorded history, learned people refused to believe that stones could come from the sky at all. Peasants would describe a flash, a thunderclap, and a smoking rock in a field, and scholars would shake their heads. Stones do not fall from the heavens, they said. The sky has nothing solid in it. The peasants must be confused. This disbelief lasted until the very late 1700s, when a shower of stones fell over the French village of L'Aigle in 1803. So many fragments came down, witnessed by so many people across so wide an area, that the matter could no longer be brushed aside. A young scientist named Jean-Baptiste Biot rode out to investigate. He gathered samples, interviewed villagers, mapped the fall zone, and returned with a careful report. After L'Aigle, the educated world finally accepted that yes, stones do sometimes fall from the sky. The records grow stranger the deeper you look. In 1492, a large stone fell near the town of Ensisheim, in what is now France. It weighed about 127 kilograms and was placed in chains inside the local church so that it could not, the townspeople said, wander away or fly back to where it came from. Parts of that stone are still preserved today, more than 5 centuries later. In 1969, a brilliant fireball lit up the skies above the village of Murchison in Australia. The stones that fell turned out to contain amino acids, the small chemical pieces that all life on Earth uses to build itself. Where those amino acids formed, and what their presence means, is a question still discussed in laboratories today. The largest single meteorite ever found sits in the ground in Namibia, in southern Africa. It is called Hoba. It weighs roughly 60 tons, and it has never been moved since the day it landed, perhaps 80,000 years ago. No one saw it fall. It was simply discovered, lying flat in a farmer's field, a slab of iron and nickel from somewhere far away, resting quietly in the African soil. What the old records do not always explain is the why. Why some meteorites land in dry pieces, and others arrive wrapped in strange smells. Why some fall in showers of thousands of pebbles, and others as a single enormous mass. Why so many cultures, working alone, came to similar conclusions about the importance of these stones long before science could confirm anything. One idea is that the sheer rarity of a witnessed fall made each one unforgettable, a story passed down for generations. Another is that something about the experience itself, the light, the sound, the heat, left a mark too deep to ignore. Both may be true. Neither fully closes the question of how the sky, every so often, decides to send something down to us. Of all the strange things that drift down from the sky, few are as quiet or as easy to miss as silk. Thin strands of spider silk, sometimes single threads, sometimes great soft sheets of tangled white, have been seen settling onto fields and fences and rooftops for as long as people have kept records. They arrive without sound. They catch the light for a moment, then vanish into the grass. And for centuries, those who saw them wondered where on earth they had come from. The old name for this falling silk is gossamer. In medieval Europe, country people would step outside on a still autumn morning and find the hedges draped in pale, shining thread. The fields looked frosted, even when the day was warm. Some called it the work of fairies. Some thought it was the unraveled robes of saints. Others believed it was a kind of cobweb rain falling gently from a sky that seemed perfectly empty. The mystery turned, slowly, on the question of how something so delicate could travel so high. Spiders, after all, are small creatures of the ground. They live in corners and crevices and low branches. Yet here was their silk, drifting down from above the clouds, sometimes from heights of thousands of feet. The leading idea today is a behavior called ballooning. A young spider, no larger than a grain of pepper, climbs to the tip of a leaf or a blade of grass. It lifts its tiny body, points its abdomen toward the sky, and releases a few threads of silk. The threads catch the breeze, or perhaps something subtler than breeze, and the spider lifts into the air. It rides the currents like a kite with no string. Researchers have collected these ballooning spiders from the tops of mountains, from the decks of ships far out at sea, and from weather balloons drifting 2 miles above the ground. The silk, once released, can travel for hundreds of miles before it falls. When many spiders balloon at once, their threads tangle together as they descend, forming the soft white sheets that startled medieval farmers. But the question of how they get airborne in the first place remains beautifully unsettled. For a long time, scientists assumed the wind alone carried them. The silk acted as a sail, and the sail caught the breeze. Yet, observers noticed something odd. Spiders sometimes balloon on days when there is almost no wind at all. They lift off in still air, climbing as if pulled gently from above. One newer idea is that the spiders are sensing electricity. The atmosphere carries a faint electric field, always present, always shifting. Silk threads, when extruded from a spider's body, may pick up a tiny negative charge. The ground beneath them often carries a charge as well. If the charges repel each other, the silk might lift on its own, independent of the wind. Some laboratory studies have shown spiders fanning their legs and tasting the air before takeoff, as if reading the electric weather. Other researchers wonder if both effects work together. Wind for the long voyage, electricity for the launch. The question is still open. The spiders are not telling what they leave behind. When they finally come down, is a kind of fingerprint of the upper air. Each strand is fine enough to pass through the eye of a needle 1,000 times over. Under a microscope, the silk shows tiny knots and barbs and microscopic droplets where the spider added a little glue. Some strands are smooth, some are beaded like a necklace. The patterns vary by species, and by the age of the spider, and by the chemistry of the air it climbed through. People have found gossamer falling in the deserts of Australia, on the plains of Texas, in the moors of Scotland, on the green slopes of New Zealand. Charles Darwin, sailing aboard the Beagle in 1832, watched thousands of tiny spiders rain down onto the ship while it was 60 miles from shore. He stood on the deck and let the silk gather on his coat sleeves. He wrote about it later with quiet astonishment, the way a person writes about a thing they cannot quite explain. This is the gentlest of the sky's strange offerings. No thunder, no crash, no broken windows, just a slow descent of threads, almost invisible, settling on the grass while the world goes about its day. Most of it is never noticed. Most of it lands and dissolves into the ground without anyone knowing it was ever there. And somewhere above, even now, more spiders are climbing onto blades of grass, lifting their small bodies toward a sky we still do not fully understand. Of all the strange things said to have fallen from the sky, the smallest creatures may be the hardest to study. A fish on a rooftop is hard to ignore. A frog hopping across a wet road draws every eye. But worms, beetles, and tiny crawling things blend into the grass within minutes. They slip between blades. They vanish into the soil. For most of human history, no one was watching closely enough to know they had fallen at all. The earliest written reports of small creatures dropping from the sky come from old farming records and parish notes. A village in Scandinavia logs a sudden carpet of earthworms after a summer storm. A monk in Central Europe writes of grubs found on a freshly swept courtyard where none had been the night before. These notes were rarely written by scientists. They were written by farmers, priests, and town clerks, people whose job was to mark unusual days for the record. The science came much later, and it came slowly. In the 1700s, a few European naturalists began collecting these stories on purpose. They wrote letters to one another, swapping accounts of strange falls the way collectors swap shells. One naturalist might describe a shower of small beetles in a Belgian field. Another might reply with a story of red worms found on a Norwegian snowbank, far from any open ground. The letters were polite, curious, and often unsure. The writers knew they were dealing with second-hand reports. They knew memory could exaggerate. Still, they kept collecting because the pattern was too consistent to ignore. The first real instruments brought to the question were simple ones: a glass jar to hold a sample, a magnifying lens to study what was inside, a careful diary to note the date, the weather, and the direction of the wind. By the 1800s, a few amateur scientists were trying to test the wormfall stories directly. They would arrive at a village hours after the event, scoop up specimens, and try to identify them. Often the worms turned out to be ordinary species, the same kinds that lived in the local soil. That raised an awkward possibility. Perhaps the worms had not fallen at all. Perhaps they had simply crawled to the surface during the rain, as worms often do when their burrows flood. This was the first great mistake, and also the first great lesson. Early investigators learned that a witness saying they fell from the sky was not the same as proof. People see worms on the ground after a storm and assume the sky delivered them. The soil, in most cases, is the simpler answer. The naturalists began to separate the reports into two piles. In one pile went the falls that could be explained by ordinary behavior, by worms surfacing or beetles swarming. In the other pile went the harder cases, tiny creatures found on rooftops, insects gathered on the decks of ships far from shore, worms wriggling on fresh snow where no soil lay beneath. Those harder cases pushed the science forward. A few researchers in the late 1800s began to study the air itself. They flew kites carrying sticky paper. They sent balloons up with small traps. To their quiet surprise, the upper air was not empty. It held drifting spiders, tiny beetles, aphids, and threads of silk. The sky, it turned out, was a kind of slow river of small living things, carried by winds at heights people could not easily reach. This discovery gave the old worm and beetle stories a new shape. If the air already held insects, then a strong updraft might gather more. A passing storm might drop them in a single place. Still, the puzzle did not close. The drifting cloud of tiny creatures explained some falls, but not others. It did not explain why worms, which cannot fly and rarely climb, sometimes appeared on snowbanks, miles from bare earth. It did not explain why certain beetle falls involved one species only, neatly sorted, when wind-borne drift tends to mix everything together. Some researchers proposed that strong storms could lift soil and its inhabitants together, sorting them as they fell. Others suspected that many reports were misread events, with creatures already present being noticed for the first time after rain washed away the leaves. The history of discovery here is a history of patient doubt. Each generation of naturalists trusted the old reports a little less and the atmosphere a little more. They learned that the sky carries more life than anyone once believed. They also learned that human memory, under the spell of a strange morning, is a difficult witness. The question of how each small creature truly reached the ground remains, even now, only partly answered. Among all the strange things people say have fallen from the sky, few feel more peaceful than hay. Soft tufts of dried grass, drifting down from a quiet afternoon sky, settling on rooftops and meadows like a slow, dry snow. It sounds gentle, almost dreamlike, and yet the reports are real, and they go back further than most people imagine. In England, in the summer of 1897, witnesses near the village of Wrexham described pieces of hay falling steadily for nearly half an hour. The sky was mostly clear. There were no nearby farms haying that day. The hay drifted down in fine sun-dried strands, gathering on garden walls and pond surfaces. Similar reports came from parts of Wales, from the American Midwest, and from the dry inland valleys of southern France. The hay was never glowing or unusual. It was simply hay falling from a place where no hay should be. 1. Quiet theory rests on the behavior of dust devils and small whirlwinds. On a hot day, a column of rising warm air can lift surprisingly heavy things. A whirlwind passing over a dry hayfield might gather an armful of loose stems, carry them high into the air, and drift for miles before letting them go. The hay falls when the rising column weakens, perhaps over a village where no one saw the lifting at all. It is a tidy explanation, but it does not always fit. Some falls have happened in still weather, with no recorded whirlwinds for many miles around. A second idea points to high, thin layers of wind that sit far above the ground. These ribbons of moving air can carry light material for great distances, sometimes for hundreds of miles. If a fire, a harvest, or a strong gust loaded the upper air with dry grass somewhere far away, that grass might drift for hours before slowly settling. The trouble is that no one can usually trace it back. By the time the hay arrives, the original field is gone from memory, lost behind clouds and distance. Seeds are perhaps even stranger. Across many centuries, people have written of seed falls, small, hard grains, sometimes unfamiliar, scattering across farmyards and city streets. In 1841, in parts of what was then southern Tennessee, witnesses reported finding many small round seeds on the ground. After a passing storm, the seeds did not match the local plants. Some thought they had come from a faraway region carried by the wind. Others wondered if birds had dropped them in flight. The seeds were collected, studied, and then, as so often happens with these events, slowly forgotten. Botanists know that seeds travel far more than most of us realize. Tiny seeds with feathered tufts can ride the wind for thousands of miles. Heavier seeds can travel inside the stomachs of migrating birds, falling to earth in places where no parent plant grows. Storms scour fields and lift loose grains into the upper air. So a seed fall on its own is not impossible. What remains puzzling is when the seeds are unusual, unfamiliar, and arrive all at once in great numbers, as though emptied from a single skyborne basket. Leaves have fallen this way too. In several reports from the late 1800s, witnesses described oak and beech leaves drifting down in autumn from a clear sky. Far from any forest, the leaves were dry, brown, and curled, as if they had been aloft for some time. One idea is that powerful updrafts at the edge of distant storms had pulled the leaves from forest canopies and lifted them high. The leaves then rode the cold upper winds until they slowly tumbled back down, somewhere else entirely. Another idea is simpler. Perhaps the leaves had been hidden in tall thermal columns nearby, lifted gently in the morning warmth, and only now returning to earth. There are stranger plant falls still. Pine needles, husks of grain, small bits of straw braided together as though combed by the wind itself. In some cases, the fall lasted minutes, in others, hours. Almost always, the witnesses describe the event with a kind of soft confusion, as if they cannot quite believe what they are watching, but cannot deny it either. What ties these reports together is the gentleness of the thing. No violence, no flash, just the soft descent of plant matter that should not be where it is. The atmosphere, it seems, gathers and carries far more than we usually notice. Whole gardens, perhaps, are moving above our heads at any given moment, drifting from one place to another in slow, invisible rivers. Why these rivers sometimes let their cargo fall, all at once and in such tidy quantities, remains a mystery the wind has not chosen to share. Of all the strange things that have reportedly fallen from the sky, perhaps none feel stranger than the falls of coins and small bits of metal, living creatures we can almost picture being lifted by storms. A frog or a fish is light. A coin is heavy, dense, and shaped by human hands. Yet the old records keep mentioning them anyway. One often repeated account comes from the town of Mascara in Russia. In the year 1940, the story goes that a storm passed over, and when it cleared, the ground was scattered with silver coins. Some were said to be hundreds of years old. The leading theory at the time was simple and earthly. A buried hoard, hidden long ago, had been uncovered by a small tornado or a powerful updraft. The wind lifted the coins into the clouds, carried them a short distance, and let them fall again as the storm weakened. It is a theory that connects two systems most of us never link together: the slow burial of human history in the soil, and the sudden lifting power of a moving column of air. There are other accounts, scattered across centuries, of small metal objects appearing in the rain. Nails, bits of iron, pieces of slag from old foundries. In some cases, the explanation is almost certainly mundane. A factory chimney releases hot air carrying tiny fragments. Those fragments rise, drift, and settle far from their source. In other cases, the truth is harder to pin down. Witnesses described objects too large to be carried on a thermal current, falling in places where no factory and no buried treasure could reasonably explain them. This is where the topic begins to braid together with so many other systems we have already touched on. The same updrafts that can lift fish from a shallow pond can, in principle, lift any object light enough to be caught in their grip. The strength of an updraft inside a thunderstorm can exceed 100 miles per hour. Hailstones the size of grapefruits are held aloft by those currents until they grow too heavy. If a storm passes low over an open field, a market square, or an old battlefield where coins lie scattered in the dirt, the same lifting force could in theory carry them upward. Whether it actually does, in the way the old stories describe, is another question entirely. Some researchers have wondered whether certain falls of metal are connected to volcanic activity. When a volcano erupts violently, it can throw tiny droplets of molten material high into the atmosphere. These droplets cool as they rise and fall as small dark beads, sometimes called Pele's tears in places like Hawaii. The connection between deep earth and open sky is direct here. A force from far below the crust sends pieces of itself into the air, and those pieces drift down again, sometimes hundreds of miles from where they began. A villager finding a small black bead in the grass after a strange rain might be holding a fragment of a distant mountain's heart. Other theories reach further. A few writers have suggested that some metal falls are simply meteoric. Tiny iron-rich fragments from space burn up high in the atmosphere and fall as nearly invisible dust. Most of this dust lands quietly, but occasionally a larger fragment survives the descent and lands in a way that startles whoever finds it. A small piece of iron on the ground after a rainstorm could be a meteor, a piece of volcanic ejecta, a flake from a passing aircraft, or something stirred up from below. Without sampling and testing each one, the truth often stays hidden. The connections keep multiplying the longer you sit with the question. The same sky that carries pollen from forests carries dust from deserts. The same winds that move seeds across continents move ash from fires. The same storms that lift water from the sea lift small swimming creatures with it. The atmosphere is not an empty space above the ground. It is a slow, restless mixing layer that gathers things from every system below it. Oceans, volcanoes, forests, factories, fields, even the buried past, and sometimes returns them in unexpected places. What no one has fully solved is how often this really happens, and how often the old stories of falling coins are simply the result of a hoard being uncovered by ordinary rain washing away the soil. Both explanations are possible. Both have supporters. The records remain, scattered across centuries and languages, waiting for someone to fit them into a single quiet pattern. For now, the metal in those old accounts sits in the same wide category as everything else this episode has gathered. Things that fell, things that puzzled the witnesses, things we still cannot fully explain. Among the older accounts of strange falls, there is a detail that often slips by unnoticed. Before the strange thing arrived, people heard something, a hum, a rumble, a whistling in the air, a sound like wind moving through a place where no wind should be. The reports come from many centuries and many countries, and they describe something witnesses could not quite name. In village chronicles from the Middle Ages, you find brief lines tucked between weather notes. A low roaring in the clouds, a drumming overhead just before the fish came down. In the 18th century, farmers in parts of Europe spoke of a humming that filled the orchard moments before small frogs began to patter onto the leaves. The descriptions are simple. The witnesses were not trying to be poetic. They were trying to record what they heard. This pattern, if it is a pattern, has shifted over time. The older the account, the more the sound is described in spiritual or omen-like language. A voice in the sky, a growl of warning. By the 19th century, newspaper writers had begun to use weather words instead. A rushing noise, a whirring. Something like distant thunder, but steadier. The thing being heard may have stayed the same. The way people named it changed. One theory is straightforward. Many strange falls happen near storms, and storms are loud. A waterspout offshore can produce a deep, droning roar that carries for miles across calm water. A funnel cloud over land makes a sound that witnesses often compare to a freight train. If a distant waterspout is the lifting mechanism, then a low rumble before the fall would make sense. The sound and the skyborne cargo would share the same source. Another idea points to the air itself. Strong updrafts, even without a visible funnel, can create odd acoustic effects. Wind moving across hills, through trees, around buildings, can hum at low frequencies that travel far. Some researchers wonder whether certain falls happen on days when the atmosphere is unusually loud in ways human ears notice only at the edge of hearing. The sound might not be a warning of the fall. It might simply be the same weather, heard before it is seen. A competing view is more cautious. Memory is a soft thing. After a strange event, people often reorder what they remember. A sound that was nothing in particular becomes, in the retelling, the sound that came just before. The mind likes patterns and fills them in. Without recordings from the moment itself, it is difficult to know how many of these reported sounds were truly there, and how many were assembled afterward, in the quiet of remembering. The way we listen to the sky has also changed. For most of human history, the air above a village was nearly silent. A person could hear a single bird half a mile away, a distant cart on a stone road, the hum of insects in a far field. In that older quiet, A faint roar in the clouds would have been unmistakable. Today, the soundscape is layered with engines, machines, and the constant low rumble of distant roads. A subtle hum from a storm a few miles out might never reach a modern ear. If strange sounds still arrive before strange falls, we may simply not be hearing them anymore. There is also the slow change in who records these events. Once, a village priest or a town clerk wrote down what happened, and the page survived for centuries. Now, accounts move through phone videos and quick posts that vanish into the flow of newer things. The sounds people hear before a sudden fall of hailstones or a brief shower of insects may be captured on a microphone somewhere, then lost in the noise of everything else being recorded that day. What remains open is whether these pre-fall sounds are a real, consistent feature of the phenomenon, or whether they are something we have been imagining for a long time. The honest answer is that no one has gathered enough careful recordings to say. Strange falls are rare. They happen without warning. By the time anyone arrives with proper instruments, the sky is quiet again, and the fish, or the frogs, or the colored droplets are already on the ground. So the question drifts forward through the centuries, mostly unchanged. People hear something, something falls. The two events sit next to each other in the memory, joined by a thread that may or may not be real. The sky keeps its old habits, and we keep changing the words we use to describe them. Somewhere between the medieval chronicler and the modern witness with a phone in hand, the same low hum may still be moving through the air, waiting for someone to listen closely enough to be sure. Picture a warm afternoon over a shallow sea. The water lies flat and silver. A low cloud passes overhead, dark on the bottom and bright at its edges. Beneath that cloud, the air begins to spin. A thin grey finger reaches down from the cloud base. The water below begins to lift, rising in a slow ring of mist. In a few breaths, a column connects sea and sky. This is a waterspout, and it is the heart of one of the oldest theories about how living things might fall from above. The light around a waterspout is part of what makes it strange to witness. The funnel itself can look almost translucent, lit from within by the pale glow of the sky. The spray at its base catches the sun and turns to a soft white halo. From a distance, a waterspout often appears slower than it really is, gliding across the water like something half asleep. Sailors have described them as columns of glass or pale ropes hanging between two surfaces. The calm appearance hides a fierce inner spin, strong enough to lift fish, frogs, and small debris into the lower clouds. The theory goes something like this. A waterspout or strong updraft passes over a pond, a marsh, or a shallow bay. It draws water upward, and with the water, it draws whatever happens to be swimming or sitting near the surface. The lifted creatures travel inside the spinning column, sometimes for many minutes, sometimes for many miles. When the storm weakens, or when its winds slow over land, the heavier objects fall first. That, some researchers suggest, is why so many animal falls involve creatures of similar size and species. The storm sorts them by weight in the sky and drops them in a sudden patch. It is an elegant idea. It also has gaps that no one has fully closed. One problem is the distance between the lift and the fall. Many recorded animal falls happen far from any body of water that could have held the creatures alive. Some falls describe fish still flopping on dry ground. Others describe frogs that hop away into the grass. For a small animal to survive being pulled into a spinning column of wind, carried into freezing air, and then dropped back down, the journey must be quick and gentle, in just the right way. The mechanics are possible. The repeated good luck is harder to explain. Another problem is the missing storm. In a fair number of reports, witnesses describe clear or only lightly cloudy skies at the moment of the fall. There is no nearby waterspout, no visible thunderhead, no obvious sign of the kind of weather the theory needs. Some scientists answer that the lifting event may have happened hours earlier and many miles away. The wind, they say, can carry small loads for long distances at high altitude, then release them when conditions shift. Others find this stretch of the theory less satisfying, because once the creatures are out of sight, the model becomes very hard to test. There is also the question of selectivity. Waterspouts are not careful sorters. They lift mud, plants, sticks, stones, and water along with any animals present. Yet many recorded falls contain only one kind of creature, a field of frogs and nothing else. A street covered in small fish, all of one species. If the lifting was indiscriminate, where did everything else go? One competing idea suggests that the falls we hear about are simply the ones people noticed, and that the boring debris fell with the animals, but went unrecorded. Another idea proposes that some kind of natural sorting happens in the upper air, separating loads by density before they descend. Light enters the story again at the moment of the fall. Witnesses often describe the sky just before an animal fall as having an odd quality, a heavy yellow tint, a strange flatness, as if a soft lid had been placed over the day. Some accounts mention a sudden hush, with the usual bird sounds gone. Whether these descriptions reflect real atmospheric conditions or the memory of a person trying to make sense of something strange, no one can fully say. The reports are too scattered and too old to compare carefully. What remains is a theory that explains much, but not all. Waterspouts almost certainly account for some animal falls. Strong updrafts in thunderstorms likely account for others. Yet a stubborn fraction of cases resists every model we have. The lifted things came down in places they should not have been, in numbers that should not have gathered, under skies that should not have allowed it. The columns of pale light reach down from the clouds, and the question still hangs in the air above them. There is a sound that deserts make when the wind lifts them into the sky. It begins as a soft hiss along the dunes, the whisper of countless grains sliding against one another. Then it rises into something like a low moan, as the air gathers strength and pulls the surface upward. In the Sahara, on the edge of the Gobi, in the wide dry basins of Australia, this sound has been heard for as long as people have lived near the sand. It is the voice of a desert getting ready to travel. What lifts on that voice can cross oceans. A storm in the Sahara can pour dust into the upper air, and that dust can ride the winds for days, sometimes weeks. It falls quietly on rooftops in Spain, on snowfields in the Alps, on car windshields in England, on the green hills of the Caribbean. Sometimes it falls so thickly that the rain itself turns the color of weak tea, or rust, or old blood. People wake to find their windows streaked with red, and they wonder what passed over them in the night. The sound of that falling dust is almost nothing. A thin pattering, if there is rain, a soft settling, if there is not. You would never guess that the silence on your porch began as a roar half a world away. For centuries, this kind of fall was a deep mystery. Villagers in southern Europe would see red rain and remember stories of omens. Some thought the sky was bleeding. Some thought a great battle had been fought above the clouds. Old chronicles describe these events with careful, worried language, and the writers often searched the horizon for the source, finding none. The desert was too far away to imagine. The connection was invisible. Modern science has, in many cases, traced the path. Satellites now watch the dust plumes leave Africa and drift across the Atlantic. Researchers can match the minerals in a red rain sample to the soils of a specific region thousands of miles distant. The pale red of Saharan iron oxide, the grey of Mongolian loess, the fine ochre of Australian outback clay, each leaves a chemical fingerprint that careful chemists can read. When the fingerprint matches, the mystery softens a little. But not every colored rain has yielded its source so easily. The famous red rain of Kerala in southern India fell on and off for weeks in 2001. Scientists collected samples and studied them for years. Most researchers now believe the red color came from the spores of a local algae, lifted into the clouds in great numbers. Others have proposed different explanations, and the debate has been long and careful. The question of exactly how those spores reached the rain, and why in such concentration, remains a topic of quiet discussion in scientific journals. So there are at least two competing pictures for any colored rain event. One picture says, distant desert, long winds, mineral dust pulled down by water droplets. The other picture says, local life, lifted spores or pollen or microorganisms, coloring the rain from within. Sometimes both pictures may apply to the same event in different proportions, and sometimes neither quite fits. The sound of these falls is gentle, almost shy. A faint tick on a metal roof, the soft slide of tinted water down a clean white wall. If you stood in a Saharan dust rain, you would hear ordinary rain, perhaps a little softer than usual, and you would only know something strange had happened when you looked at your hands and saw them stained. There is something quieting about the idea that the air above us is always carrying things. Tiny grains from places we have never visited, spores from forests on the other side of the equator, salt from oceans we will never sail. The sky is not empty. It is a slow, patient river of matter, moving from one continent to another, and we walk beneath it without noticing. Researchers still do not fully understand how much material the atmosphere moves in a given year. Estimates vary widely. The mechanisms that lift the heaviest particles into the highest layers remain partly mysterious, and the question of which falls are dust, which are life, which are both, and which are something not yet identified, is still being worked out, one sample at a time. For tonight, it is enough to picture the long, quiet journey. A grain of red sand lifted from a dune at sunset, a week of drifting through cold, thin air. And then, softly, a small ticking sound on a window far from home. The sky has dropped off a visitor and gone on its way, still humming its low and ancient song. There is a soft mystery that walks the fields of old Britain and Ireland, and many other places in the world. People call it star jelly. They walk out in the cool morning, after a strange night, and they find small lumps of clear or whitish jelly resting in the grass. The lumps shimmer a little in the dawnlight. They feel cool to the touch, and no one is quite sure how they got there. The name itself is very old. For hundreds of years, country folk believed these soft pale lumps had fallen from the stars. They saw a meteor cross the sky one night, and the next morning they walked out and found jelly in the meadow. The two events seemed linked. The word for it in old writings was sometimes pondresseur, a Welsh phrase that means the rot of stars, a poetic name for a quiet little puzzle. The math of meteors is one of the most beautiful in all of science. A small piece of rock or metal drifting in space meets the edge of our atmosphere at tens of thousands of miles per hour. The exact speed depends on the angle of approach, and the path of Earth around the Sun. Astronomers can predict where many meteor showers will fall, almost to the hour, year after year. The Perseids return in August. The numbers behind these returns are elegant and patient. Earth swings through the same dusty trail at the same point in its orbit, and the sky lights up on schedule. So you might think the math would solve the star jelly riddle. If a meteor fell on Tuesday night and jelly appeared on Wednesday morning, the chain seems clear, but the math says something different. A meteor that survives its blazing descent is almost always a small, dense stone. It is not soft. It is not jelly. It has been heated to a glow and then cooled in the high, cold air. The pieces that reach the ground are pebbles and grit, not soft, pale blobs in the grass. The numbers do not match the legend. This leaves the open question wide and quiet. If the jelly is not from the stars, what is it? Several ideas have been gently floated over the years. One is that the jelly comes from frogs and toads. When predators eat a female frog, they sometimes leave behind the unfertilized egg masses inside her body. Those egg masses can swell with water in the wet grass and form clear, soft lumps. Birds and foxes may drop these jellies as they hunt. Some studies have tested star jelly and found frog DNA inside. That seems to settle part of the puzzle, but not all of it. Other samples have been tested and have shown no animal DNA at all. Some lumps appear to be a kind of slime mold, a strange living thing that creeps very slowly across the ground in moist weather. Some seem to be cyanobacteria, tiny living cells that swell into jelly when they soak up rainwater. A species called nostoc is often blamed. It can lie dry and almost invisible for weeks, and then bloom into a soft blob after a heavy rain. The math of its swelling is simple. A thin film of cells plus water equals a surprising amount of jelly. So the answer may be several answers braided together. Some star jelly is frog, some is bacteria, some is fungus, some is slime mold, and some even now refuses to give up its secret in the lab. A few well-studied lumps have shown almost no organic content at all. They seem to be mostly water, held in a strange thin matrix with nothing alive inside. Those samples remain a quiet puzzle. The numbers of nature are sometimes very clean. The orbits of comets, the cycle of seasons, the ratio of a spiral shell, the drop rate of a falling stone, the same on every continent on Earth. These rules feel like music, but the soft, small mysteries, like a lump of jelly in a wet field at dawn, do not always sit neatly inside the music. They wait at the edges. They remind us that the elegant laws of physics still leave room for unsorted things. A clear, cool blob on a green leaf, a village rumor of a meteor the night before, a scientist gently lifting the jelly into a small glass jar and carrying it home to ask its name. The math gives us the meteor. The math does not yet give us the jelly. The question stays soft and unresolved, resting in the grass, waiting for the next quiet morning. Among the strangest accounts in the long history of skyfalls are those that describe light, not lightning, not the bright streak of a meteor, but a soft glow that seems to travel with the falling matter itself. Witnesses have written of rain that shimmered as it came down. They have described stones that arrived warm and faintly luminous. They have spoken of falling jellies that pulsed with a pale blue or green light in the wet grass. These reports are rare. They are also stubborn. Across centuries and across very different cultures, the same odd detail keeps appearing in the records. Something fell and something glowed. One gentle possibility is that the glow was real, but ordinary. Many living things on Earth produce their own light. Certain fungi shine softly in damp forests. Some plankton flash when the sea is stirred. Tiny worms, certain beetles, and a few kinds of jellyfish carry chemicals in their bodies that give off a cool, steady light. If a waterspout or strong updraft happen to lift a patch of such creatures from a bay or a marsh, and if they survive the trip through the clouds, they might well land still glowing in a field at night. A farmer walking out at dawn would see only the strangeness, not the cause. Another possibility is that the glow had nothing to do with life. Lightning during a storm can leave the air rich with charged particles. Falling water droplets can carry small static charges of their own. In rare conditions, this can produce a faint shimmer in the rain, a soft halo around objects, even brief flickers along fences and wet branches. Sailors have long described a similar glow on the masts of ships during certain storms. The light is real, the cause is electrical, and it fades when the storm passes. There is also the question of meteoric dust. When a small space rock burns up high in the atmosphere, it leaves behind a long trail of tiny particles. These particles drift down slowly over hours or days. If they happen to fall through a rain cloud, they may ride the droplets to the ground. Some of these particles can briefly glow as they enter the lower air, though by the time they reach a person's hand, they are usually cold and dark. Still, eyewitnesses sometimes describe seeing a faint shine in the sky just before a strange rain. Whether the two events are connected, or whether the human mind simply links them, remains an open question. It is worth pausing here to wonder at how delicate all of this is. The atmosphere that carries these strange falls is a thin shell of gas wrapped around a stone world. If you could shrink the earth to the size of an apple, the breathable air would be thinner than the apple's skin. Within that thin skin, water rises and falls, storms gather and break, and now and then something unexpected is lifted up and set back down somewhere new. The conditions that allow any of this to happen are remarkably specific. The Earth sits at a distance from the Sun, where water can exist as liquid, vapor, and ice all at once. The planet spins fast enough to mix its weather, but not so fast that storms tear the surface apart. The air holds just enough moisture to form clouds, just enough oxygen to support flying creatures, just enough pressure to lift droplets and let them fall again. Change any of these by very much, and the sky goes quiet in a different way. There would be no rain to color, no clouds to lift fish, no soft glow in the wet grass at midnight. The mystery of the glowing falls fits inside this larger wonder. We do not fully know why some witnesses, on some nights, in some places, saw light where there should have been only water. Several explanations may each be partly true. Living things that glow, electrical shimmer in storm air, drifting dust from far above, and the simple way human eyes adjust to darkness may all play a role. None of these has been proven for any single recorded case. The events were too brief, the samples too scarce, the witnesses too scattered across time. So the question stays open, like a window left ajar in a quiet room. Somewhere, on some future night, a soft rain may fall on a field, and a faint light may move through it, and someone may have the patience and the tools to gather a careful sample. Until then, the old accounts wait in their books, gentle and unexplained, asking us to imagine a sky that sometimes carries its own small lanterns down to the ground. When a volcano wakes, it sends more than smoke into the sky. It lifts ash, gas, glass, and small stones high into the air. Some of these particles travel for days, some travel for weeks, and when they finally fall, they can land on towns thousands of miles from the mountain that made them. For centuries, people have looked up at strange skies after a far-off eruption and wondered why the rain came down grey, or why small dark stones tapped on their roofs from clouds that seemed too soft to carry them. The simple part of the story is well understood. A large eruption can push ash high into the upper air. Winds in that layer move fast and steady. They carry the fine particles around the world. When weather pulls these particles back down, often inside raindrops, the rain may look milky or rusty or even faintly green. People living far from any volcano have written about such rains for as long as they have kept records. Roman writers described skies that dropped ash on quiet afternoons. Medieval monks noted grey dust on their windowsills after no storm at all. The harder part is what counts as a volcanic fall and what does not. A clear case is easy. A volcano erupts, the wind blows a known direction, and ash lands where the models predict. But many old reports describe small stones falling from skies that seemed calm, with no known eruption nearby. Some of these reports may belong to meteor falls. Some may belong to dust storms that were never recorded. Some may belong to volcanoes too distant for the witnesses to know about. Sorting these stories apart, hundreds of years later, is slow and gentle work. One question still open is how small a particle can be lifted, how far it can travel, and how heavy a stone the upper air can carry. Fine ash is light and floats easily. Pumice, that soft, foamy volcanic rock full of tiny holes, is light too, and pieces of it have been found drifting on the ocean, far from their source. But the harder, denser bits seem to fall closer to the volcano. The puzzle is that some old accounts describe small dark stones landing in places where no nearby eruption was active. Researchers still debate whether such stones were truly volcanic or meteoric, or something else entirely. Another open question is what colored rains really carried. When ash mixes with water in a cloud, the droplets often turn gray, but some falls have been red or yellow or pink. One theory is that desert dust mixed with volcanic particles in the upper air, painting the rain a warmer shade. Another theory is that certain eruptions release iron-rich material that stains the water as it falls. A third theory leans on tiny organisms, algae, spores, pollen, caught up by the same winds. In many cases, no one sampled the rain in time to find out. The color faded, the puddles dried, the mystery stayed. There is also the strange matter of timing. Some communities have reported ashy rain weeks or even months after a distant eruption. The fine particles can drift in the high air for a long time before something pulls them down. Predicting where and when they will fall is still difficult. Computer models have grown sharper, but the upper air is a slow, wide, churning place, and small surprises hide inside it. A particle that left a mountain in spring might come down in autumn, far from any line a map would draw. What makes this part of the story feel unresolved is the overlap with everything else this episode has gentled through. Volcanic dust can stain rain like Saharan dust can. Volcanic stones can fall like meteorites can. Volcanic ash can hold spores and tiny living things the way ordinary winds can. When witnesses describe a strange fall from long ago, researchers often face a soft puzzle with several possible answers and no way to test which was true. The volcano is one suspect among many. What remains genuinely exciting is how much we are still learning. Satellites now watch ash plumes in near real time. Chemists can read the fingerprint of a single grain and trace it home. New cores drawn from ice and lake mud reveal old eruptions that history forgot. With each finding, some of the old stories grow clearer, and some grow stranger still. A colored rain from a quiet medieval afternoon may yet be matched to a faraway mountain we did not even know had stirred. For now, the sky keeps its share. Day. Volcano speaks. The wind listens. And somewhere, eventually, the stones and the dust and the ash drift gently down, sometimes onto a place no one expected, leaving small grey marks on the rooftops of the curious. Old newspapers hold a kind of magic that is hard to describe. Their pages are yellowed and brittle. Their ink has faded to the color of weak tea. And tucked between the weather notes and the market prices, you can find small stories that someone long ago thought worth writing down. A shower of fish in a country village, a fall of small frogs near a market square, a rain that came down the color of rust on a quiet afternoon in spring. These accounts were often printed in just a few lines. A name, a place, a date, a short description of what fell and how the local people reacted. No grand claims, no theories, just a record that something strange had happened and that ordinary people had seen it. In the 1800s, newspapers across Europe and North America began to collect these reports more often. The telegraph had arrived. News could travel quickly from a small town to a city desk, and editors, perhaps sensing the quiet wonder of these events, gave them a little space among the other news of the day. A farmer found minnows in his cabbage patch after a storm. A school teacher saw frogs falling on the road as she walked home. A widow in a village reported a red rain that stained her white sheets on the laundry line. The witnesses came from every walk of life: farmers, sailors, teachers, children, priests, soldiers walking back from a long march. Some were known to be careful and steady. Some were strangers to the editor who printed their words, but the accounts share a quiet sameness across hundreds of years and many languages. A sudden sound, a strange rain, the slow gathering of neighbors to look at what had landed. What will happen to these old records in the long centuries ahead? Many of the papers themselves will not survive. Newsprint is fragile. It crumbles to dust in less than 100 years if it is not cared for. Already, libraries are racing to scan the old pages into digital form. Yet digital records have their own troubles. File formats change, storage systems decay. The careful work of one generation can become unreadable to the next. Still, some of these accounts will likely survive in some form. They will be quoted in books, in studies, in collections of curious events. They will be passed down the way old stories are always passed down. Copied, retold, slightly changed, but kept alive by the simple fact that people find them interesting. A million years from now, if there is anyone left to read, some version of these reports may still exist in some kind of memory. The continents themselves will have moved by then. The shape of the coastlines in those old newspaper maps will be gone. Rivers will have cut new paths. Whole towns will lie beneath new layers of soil. The places where the strange falls were recorded will not be findable on any future map. Yet the events themselves, if they happened in a sky that future people may still look up at. A billion years is harder to imagine. The sun, over such a long time, will slowly grow brighter and hotter. Earth's oceans may begin to thin. The atmosphere itself may shift in ways that change how clouds form, how storms move, how water rises and falls. Whether strange falls will still happen in such a future is one of the open questions. Perhaps the same physics, the lifting power of strong winds, the gathering of small things into rising air, will still produce odd showers in odd places. Perhaps the air will be too thin or too still for such events. Perhaps the things that fall will be entirely different from frogs and fish, and in much longer time, the sun will swell into a red giant, and the earth as we know it will end. The old newspapers will be long gone by then. Their words, their witnesses, their small puzzled notes would have vanished with everything else. But for now, the old pages still exist. You can hold them in gloved hands in a quiet library, or read them on a screen in the middle of the night. You can see the careful handwriting of a reporter who took down a farmer's words on a rainy afternoon in 1860-something. You can read about a fall of fish in a village whose name has changed 3 times since. These accounts do not prove anything by themselves. They are not science. They are something gentler. They are a record that people again and again looked up and saw something they could not explain and felt it worth setting down. Step back now, as far back as you can, and look at the whole of it. All these strange falls, gathered across centuries and continents, form a quiet pattern that science has been slowly trying to read. Some of the pattern is clear. Much of it is not, and the space between what we know and what we do not know is where the wonder still lives. Science can explain, with reasonable confidence, why dust from the Sahara tints rain in Europe red. It can describe how high winds lift fine particles into the upper air and carry them for thousands of miles. It can model the way waterspouts pull water and small creatures into their spinning columns. It can study the chemistry of black rain after great fires and trace the soot back to the forests that burned. These are real answers, slowly assembled over generations of patient work. Science can also explain, in broad strokes, how a strong updraft might lift a school of small fish from a shallow pond. It can show how ice grows in layers inside thunderclouds, becoming the heavy hailstones that sometimes crash down. It can identify pollen and algae and the spores of distant plants drifting on the wind. Many of the strangest falls, once examined carefully, dissolve into these gentle, ordinary mechanisms. And yet, science cannot yet explain everything. It cannot fully account for why frogs sometimes fall without any fish beside them, when both share the same pond. It cannot say with certainty what colored the Kerala rain, or why similar red rains have been reported, on and off, for 2,000 years. It cannot tell us where star jelly truly comes from, or why eyewitnesses across distant cultures have described the same soft, trembling substance in their fields. The questions remain open, waiting. There is a humility in this, and a kind of beauty. The atmosphere is not a simple thing. It is a vast, moving ocean of air, full of currents we cannot see, carrying particles and pollen and tiny living creatures we are only beginning to catalogue. Researchers now speak of the aerobiome, the living layer of the sky, where bacteria and fungi and microscopic life drift on the wind. The air above us is not empty, it is full. When you place these strange falls inside that larger picture, they begin to feel less like oddities and more like glimpses of a planet that is constantly mixing itself. Water rises and falls. Dust travels from one continent to another. Birds migrate in vast, invisible rivers. Insects ride the jet stream. Spiders drift on silk through the high, cold air. The sky is not a ceiling. It is a current, always moving, always carrying, and we are part of it. The calcium in your bones came from the long, slow death of ancient stars. The iron in your blood was forged in stellar furnaces before the earth existed. The water inside you has been rain and ocean and river and cloud. Many times over, the atoms in your breath were once inside trees and whales and stones and storms. Everything that falls from the sky is, in some sense, already part of you, and you are already part of the sky. This is the widest view science can offer, that the strange things falling from the clouds are not separate from us, but expressions of the same restless planet that made us. The frog in the field, the dust on the windowsill, the ice in the hail, the colored rain on the stones of an old village. All of it is the earth talking to itself, moving its pieces around, rearranging the long inventory of matter it has carried for 4.5 billion years. There is comfort in that. The mystery is not a wall, it is an invitation. Every unsolved fall is a place where the world has more to teach us, and where patient minds in the years to come may find a quiet answer or a quieter question. Science does not need to know everything tonight. It only needs to keep looking, gently, carefully, with respect for what it has not yet understood. And you do not need to know everything tonight either. You only need to rest. The atmosphere will keep moving while you sleep. Dust will travel, pollen will drift. Somewhere perhaps a small rain will fall with the faintest tint of something far away. The sky will keep its older secrets and offer up, now and then, a softer one. We may understand more in our lifetime. We may not. For now, it is enough to lie still and breathe and let the wonder settle softly around you like a quiet falling thing. And so we come to the quiet end of our long wandering together. The sky above you tonight is the same sky that has dropped fish into village squares, scattered red droplets across ancient cities, and let strange soft jellies rest in morning grass. It is the same sky that puzzled Roman scribes and medieval monks, the same sky that puzzles careful scientists today. Nothing about it has changed in all those centuries. Only our questions have grown deeper. Picture the earth for a moment, from a calm distance, a round blue world wrapped in a thin shell of moving air, turning slowly in the dark. The clouds drift in white spirals over warm oceans. The deserts glow soft gold under the sun. The poles wear their pale caps of ice. And around all of it, the atmosphere holds everything together. A fragile breath of gas, no thicker than the skin on an apple. Inside that thin breath, the strangest things travel. Tiny spores rise from forests and ride the wind for thousands of miles. Salt crystals lift off the sea and seed new clouds. Pollen from one continent settles gently on another. Dust from the Sahara feeds the trees of the Amazon. The sky is not empty. It is a slow, quiet river, full of life and matter, always moving, always carrying small surprises from one place to the next. Now and then, that river drops something we did not expect. A handful of frogs in a meadow, a scatter of small fish on a country road, a bowl of red rain in a startled village. We have given these events many names across history, and we have tried many explanations: waterspouts, updrafts, distant dust, algae blooms drifting through the clouds. Each idea explains some of the cases. None of them explains them all. The mystery stays gently open, like a door left ajar in a quiet house. Maybe that is the most peaceful thought to carry into sleep. Not every question needs an answer tonight. Some questions are meant to keep us company for a long, long time. They are gifts in their own way. They remind us that the world is older than us, larger than us, and still full of corners we have not yet looked into. The mystery is not a problem. It is a doorway. Somewhere right now, the sea is rolling under the moon. A long silver path of light stretches across the calm water. Tiny living things glow in the wake of slow waves. Above the sea, a single cloud is drifting, carrying who knows what inside it. Maybe nothing but water, maybe a little dust from a distant desert. Maybe a few small creatures lifted long ago by some storm we will never hear about. The cloud moves on, gentle and unhurried. In a forest somewhere, the night air is cool and still. A soft fog settles between the trees. Drops gather on the leaves and fall one by one to the moss below. Each drop has traveled a long way to be there. Each drop holds a small history of the sky. The forest does not ask where the water came from. It simply receives it and grows. In a desert somewhere, the sand has gone cool under the stars. A breeze lifts a few grains and carries them up into the dark. Those grains may travel for days or weeks. They may fall as pink dust on a far mountain. They may tint a rain shower in a country whose language they will never hear. The desert lets them go without worry. The sky receives them without explanation. You are part of all of this. The air in your room tonight has touched mountains and oceans and forests you have never seen. It has carried particles from places older than any city. It moves in and out of you with every slow breath, a quiet exchange between your small warm body and the vast gentle atmosphere of the earth. So rest now. The planet is turning under you, calm and steady. The clouds are doing their slow work above. The sky will keep its secrets a little longer, and that is all right. We may understand more in our lifetime. We may not. For tonight, it is enough to lie here and know that the world is still full of wonder, and that wonder is a soft thing, not a sharp one. It is enough to let the questions drift like clouds, and to let yourself drift with them. The sky we still look up at is the same sky that watched over every generation before us. It will watch over you tonight. Subscribe for a brand new Earth topic every night. One tap and something wonderful is waiting for you tomorrow. Sweet dreams.